Hello everyone, I'm Asma Badrawi from the University of Minnesota. In this video, I will talk about my latest research project titled Domain-Aware Grade Prediction and Top-End Course Recommendation. I'll explain the project in a simple way, but if you'd like to go into the technical details, you can check the published research paper for the project, and you'll find the link to that paper in the video description. Okay, let's start. As many of you know, the U.S. has one of the highest college dropout rates in the developed world. And moreover, a student takes an average of 6 years to complete a 4-year college degree. And these issues are caused by many reasons, including inefficient college advising and the lack of a clear enrollment plan. And so students sometimes take unnecessary courses, which increases their time to graduation. In this research project, we explored how automated course recommendation can help alleviate these problems. So, automated course recommendation involves 2 tasks. The first one is generating personalized course rankings for each student given his academic background. And the second one involves predicting the student's grades in the courses that they consider taking in the next term. We think that accomplishing these 2 tasks can improve college advising by helping students find suitable courses and by helping both students and educators make informed decisions about future course enrollment. So there are many existing recommendation techniques that are already used in commercial and social media domains for rating prediction and item ranking. However, there are special characteristics for the educational domain that the existing recommendation techniques were not designed to take into consideration. These characteristics can be summarized in one sentence, which is that students of certain academic features, like certain majors and academic levels, tend to enroll in courses of certain subjects and levels. And this creates what we call the grouping structures in the data, and this also means that the patterns in the data are not missing at random, but they are determined by the student and course features. So the question becomes, how to make the existing techniques account for the characteristics of the educational data? And that's the question that we try to answer in this project. And the idea was to explicitly model the student and course grouping structures in the data using the academic features. So we used these features to define student and course groups, and then we incorporated these groups into the existing recommendation methods in order to make them better suited for grade prediction and course ranking. By this, we mean that the whole set of courses is divided into groups based on the course subject, for example, and these groups can be further divided based on course level. And the same thing with the student groups, which can be defined based on the student's colleges, majors, and academic levels. And then the grade of a certain student S in some course C would be predicted based on how students in the same group as S performed in C, and based on how S has performed in other courses that are in the same group as C. For example, the performance of a freshman computer science major student in some 4th level electrical engineering course would be estimated based on how computer science students perform in that course, and also based on how that student performs in other electrical engineering courses that he has taken. And course ranking is also done based on the same idea. And as you might have already noticed, the groups can actually be defined at various levels of granularity using various amounts of features. And the more features we use to define the groups, the more homogeneous they become, but they also become smaller in size. And this means that we can define multiple student and course groups, and we can actually use this property to build ensemble predictive models utilizing the different groups, which can further improve grade prediction accuracy. And as I said, we incorporated these groups in some of the most popular existing recommendation methods, namely matrix factorization, user-based collaborative filtering, and popularity-based ranking. By evaluating the modified recommendation methods versus the original ones, our results showed that the modified methods gave more accurate grade predictions and personalized course rankings than the original methods, and our results also showed that the ensemble predictive model gave the most accurate grade predictions as compared to all the other methods. Thank you for watching the video. I hope you enjoyed it. And don't forget that the link to the project's research paper is down there in the video description. Bye!